Hello students, welcome back. In this video, we are going to discuss a numerical example on circular queues. In the last video, we discussed circular queue. What are circular queues? So, if we just see that concept again briefly. So, circular queue is exactly same as linear queue. You see this queue, right? We have seen this many times. This is exactly similar to the linear queue. The queue which we use to implement linear queue operations. Only thing is, this is circular because when we reach to the last location, we wrap around, right? We wrap around, that means we give this kind of movement to F and R. So because of that movement, this is called a circular queue, right? So the formula which we used for that wrap around or that circular movement was R equal to R plus 1 mod size is 5 in this case, right? And similarly for F is equal to F plus 1 mod size. Right? This is one thing. The other thing is the QMT condition here. If I write here as circular queue, circular, and here linear. For implementing both queues, the same data structure or same ADT, abstract data type, we will use. Here the movement is circular, here the movement is linear, and F is equal to F plus 1, right? The other difference is, this is the first difference between circular and linear queue. Difference and similarity will write, not only differences. Here the QMT condition is F equal to minus 1 or R equal to minus 1. Here also the QMT condition is F equal to minus 1 or R equal to minus 1. Same QMT condition. Then what is Q full condition? Here in linear queue, right, we know that the Q full condition is, this was 1, 2. The Q full condition here is R equal to size minus 1. That means R is pointing to the last location, or R is storing the last index of the array, last location of the array, right? That is Q full condition here. Here the Q full condition is R plus 1 mod size minus size, that is equal to F. R after incrementing, if that is equal to F, then that is the Q full condition, right? Whatever value of R, we will increment it by 1 in the circular fashion, and if that incremented value of R is equal to F, then the queue is full. So these are the some differences and similarities between circular queue and linear queue. Now let us perform this circular queue numerical, solve this numerical example on circular queue, right? So the first thing is NQ, right? Now whether it's the circular queue or linear queue, right? So while before performing NQ operation, we have to check if the queue is full, right? How will I check queue full? Here in circular queue, right? So this formula, right? This formula I'll use to check if the queue is full before performing NQ operation. Now in this case, how will I do that? R plus 1, which is R is minus 1, plus 1 is 0. So 0 mod size is 0, and is it equal to F? No, F is minus 1, right? So that means they are not same, the queue is not full. Now if the queue is not full, then I'll go to go and insert this 10. How will I insert this 10? Right? Now again, for insertion, we saw in linear queue there are two possibilities, right? So I'll write the steps here quickly. Check full, answer will be either yes or no. If yes, overflow. And how will you check full? Use this formula. Check whether it's full or not, use this formula. And when the answer is no, again there are two possibilities. First is queue empty? If queue empty means is R equal to minus 1? Yes. If yes, then set F equal to R equal to 0, and insert on the zeroth location. Insert on the zeroth location. If no, that means the queue is not empty, it's partially full. Then what you do? Increment r in the circular fashion, r equal to r plus 1 mod size, right? And then go to data array. In data array, on r location, insert the element, right? Let's say x. That's the circular, that's the insertion procedure, which is very similar to the insertion or enqueue procedure for linear queue, right? Only thing is this formula, right? This formula. Here, this is circular movement, right? So let us do this. So let me create some space here for doing this enqueue operations. Okay, so first enqueue10, I'll check is queue full. No, queue is not full. The second question is queue empty? Yes, queue is empty. So what you do? Set f and r to 0. Why 0? Because this is the only element, first element, and that is on 0th location. So f and r will be 0, and insert 10 there. Yeah. 10 inserted. 20. Is queue full? How will I check? R plus 1. R is 0. 0 plus 1 is 1. So I'll check queue full, right? Inserting 20, right? To insert 20, full. Is it full? How will I check? R plus 1 mod size is 5 here, size of the array. Is it equal to f? Is it equal to? Question mark means is this equal to? Right? Is it equal to f? So let's do it. So here r is 0, 0 plus 1 mod 5. Is it equal to f? F is 0. So 0 plus 1 is 1, 1 mod 5 is 1, 1. Is it equal to 0? No, it's not equal to 0. That means the queue is not full, right? Queue not full. Then if queue not full, simply increment r, right? By using the same formula, r equal to, now I am assigning the value to r. Here I did not assign, I simply extracted the value and just made the comparison here. So now I am assigning the incremented value to r, which is 1 in this case, because r is 0, 0 plus 1 is 1, 0 plus 1 is 1, 1 mod 5 is 1, so r becomes 1, right? Incremented in the circular fashion, right? So r becomes 1, so we go to location number 1 and insert 20 there, right? To insert 30, what will I do? I'll check is the queue full by using the same formula. I'll find that queue is not full. How will I check? Using this formula, r plus 1, 1 plus 1 is 2, 2 mod 5 is 2, and f is 0. So 2 is not equal to 0, that's why the queue is not full, right? Then r equal to r plus 1 mod 5, right? Assign the incremented value to r, right? So r is 2 and insert 30 there, right? So inserted this, right? Now dequeue. What is the dequeue procedure? I'll write the dequeue procedure here. Whether it's a linear queue or a circular queue, the dequeue is again same. First dequeue, right? So let me take another color here. For dequeue, so is queue empty? Is empty? That's the question you will ask, right? The answer will be yes. How will I get answer yes? Just look at the value of f. If f is minus 1, the queue is empty, right? If yes, print underflow. The answer will be no, right? If the answer is no, that means the queue is not empty. We can remove some element from the queue, right? When the queue is empty, we cannot remove, right? If the queue is not empty, that means we can remove an element, right? Now, removing procedure is similar to the procedure which we saw for the linear queue. First, get an element from the queue. In X, extract that element from data array from location F. From location F, whatever F is, remove an element from that location. In this case, F is 0, so get an element from 0th location in data array. So data of 0, that will give us 10, right? Now after removing that element, check the element which I just now removed, was it the only element in the queue, right? Was it the only element in the queue which I just now removed? If yes, is only. The next question after extracting this is only. Is this the only element? Answer will be yes or no, right? And how will I check is it the only element? It's simple, right? F is equal to R, F is equal to R. If F is equal to R, that is the only element, right? So how will I check? Is only F equal to R. Yes means F is equal to R. That time, right? So F and R will be same when in only in two cases. When the queue is empty, that is F will be -1, R will be -1. In the other cases, F and R will be uh, uh, same when there is only one element, right? So F and R will be equal in two cases. First is the queue empty, other is there is only one element in the queue. That time only, but we already made sure the queue is not empty, that's why -1 possibility is not there. And when F and R are not same, the queue is containing more than one element. So in this case, I will follow this path, and what will I do? I'll simply, so if there is only one element, what will I do? And I have just now removed that, right? So that time I'll set F and R to -1, right? And if there are more than one elements, what will I do? I'll simply increment F by +1 in the circular fashion, right? F +1 mod size, circular fashion I'll increment. Okay, this is the DQ algorithm I'll use for DQ here. So DQ. So what is the DQ process? The first question is Q empty? No, Q is not empty because F is not -1. See, I'm again telling, when I talk about DQ operation, I will be talking only about F. I'll be using only F. When I'm talking about NQ operation, I'll be talking or I'll be using only R, because F and R are the two ends we saw. They are similar to the two ends of the real life queue, the front end and the rear end, right? That's why we in the real life queue also, the insertions or NQ, or the people enter the queue from rear end and they are deleted or they are removed from the queue from the front end, right? So that's why DQ means F front and NQ means rear. Now let's perform this DQ operation. So let me take another color here. We perform DQ once, right? So process is Q empty? Check F is not -1, so its Q is not empty. Then get an element in X from the data array. X is equal to data of F, right? So data of F is 0, right? So data of 0 is 10. So 10 is removed from the queue, and after removing that 10, right, do not immediately increment F, right? Simply do not increment it by 1. Now here check the element which is just now removed, was that the only element in the queue or there are more than one elements, right? So how will I check that? Is F equal to R? No, F is 0, R is 2. That means the element was not the only element. There are more than one element, so we'll increment F by 1 in the circular fashion. So F is equal to F +1 mod size here is 5. So 0 plus 1 mod 5. So 1 mod 5 is 1, right? So remainder is 1. So F is incremented by 1. And though we are using circular formula, I said till this point, if you increment, that will be similar to the linear increment, right? So after performing one DQ, we have this situation where F is 1, R is 2. So let me clear some stuff from here. Okay, so this is the situation so far. R is 2 and F is 1. Now this operation is done. So this is done. Let's do this operation, NQ. NQ 40. Again, this formula is Q full is R. How will you check that? R plus 1 is R plus 1 mod 5 equal to f. Is it so? So r is 2, 2 plus 1 is 3, 3 mod 5 is 3. Is it equal to 1? No, it's not equal. That means the queue is not full, right? Queue is not full. We will follow this path. Then check, is queue empty, right? Queue empty. So check r. R is not -1, so the queue is not empty. So then follow this path, right? What is this path? Like increment r by 1 in the circular fashion. So r equal to, now r equal to r plus 1. R is 2, 2 plus 1 is 3. So 3 mod 5 is 3. So r is 3. And then go to data array on 3 location and insert this 40 there. So 40 is inserted. So for inserting 50, and again same process, check queue, check if the queue full. No, queue is not full in this case. By using this formula, we'll come to know that r plus 1 is 4, mod 5 is 4. So r will be 4 and 4 is not equal to 1, right? So the queue is not full. Is queue empty? No, queue is not empty. R is not -1. Then follow this formula, increment r by 1 in the circular fashion. So r is already 3. So 3 plus 1. See, when I am doing this comparison, right, this is the temporary increment, right? I am not assigning this value to this r. Otherwise, people may get confused, right? But they may think that already I have incremented r by 1. So again, if I increment, it is getting increment twice. No. Here, this incremented value, right? This I am not assigning to the r variable. I am not saying that r equal to r plus 1 mod 5. No. That means this r is not changing, right? I am just extracting the value of r, right? And doing this calculation for calculation purpose, right? I am not storing that result here, right? But here, after while inserting, I am storing the result, right? While inserting, I am storing the result. Now I am saying here r equal to r plus 1. So r was 3, right? R is equal to r plus 1. 3 plus 1 is 4. Mod 5 is equal to 4. So now r becomes 4. And then I am going to the data array on location number 4 and inserting this 50 there, right? So this is the situation so far. Again, let me have some space. So let me use, let's say, now r is 4. So this operation over. Let's perform dq one more time. So dq again, first question, before removing, check if the queue empty. Queue is not empty because f is not -1. Then follow this path, remove the element from f location, right? So f is 1, remove element from 1, right? Check was that the only element? Check f and r. F is 1, r is 4. They are not same. That means there are more than one element. Then increment f by 1 in the circular fashion. F is 1, 1 plus 1 is 2, 2 mod 5 is 2. So f will become 2, right? So this is the situation after doing dq once, right? Okay, now nq. So if I do nq now, right, 70, right, 70, nq 70. Had this been linear q, I would have concluded r is equal to 4, which is, that means r is size -1. R is storing the last index, or r is pointing to the last location. That means the queue is full, had this been the linear queue. But in circular queue, I am not doing that. When r reaches to the last location, I am wrapping it around, right? I am making r 0, right? And if that 0 location, right, I am checking in the circular fashion, right, by saying r equal to r plus 1, right, or r plus 1 is r plus 1 mod size equal to f, right? So what I am doing now here, right, when for enqueuing 70, same process I'll follow. Is queue full? Is full. How will I check that, right? Simply check r plus 1 mod 5 is the size of this array. Is it equal to f, right? See this calculation, right? I am not assigning this value immediately here. I'm just getting the value of r, doing this calculation, and I'm checking whether the next location, so this will give me next location in the circular fashion, right? So that next location is equal to f, right? So r is 4 plus 1 mod 5, is it equal to f is 2. So 5 mod 5, this is 5 mod 5, that is 0. Is 0 equal to 2? No, right? That means f is pointing on some other location, f is some other location, right? And r is when I will take r to 0, that is this location, f is on some other location, that means this location is not occupied, this location is empty, this location is empty, right? So I can insert an element here. Now after checking this, that the next location is not full, right? The next location is not full, it's empty. Then I increment my r. Then I say r is equal to r plus 1 mod 5, which is 4 plus 1 mod 5, which is 5 mod 5, which is 0. Now r becomes 0. Now r is becoming 0, right? And then we are going on 0th location and inserting this 70 there. Now 70 will come here. Now this location is occupied. Now you see, we have a situation where f is greater than r. So that is possible in circular queue, but in linear queue, f will never be greater than r, right? Either f will be less than r, or f will be equal to r, right? But it will never be greater than r. But in circular queue, any situation is possible. Okay, to insert 80 now, same way, right? So queue is not full, it's not empty, right? So we'll follow this path, increment r in the circular fashion, r equal to r plus 1, r equal to 0 plus 1 is 1, 1 mod 5 is 1, right? So I said use this formula, r is 0, 0 plus 1 is 1, 1 mod 5 is 1. So now r becomes 1, and then I'll go on location 1 and insert 80 there. So 80 is inserted here, right? Okay, now here is now we'll insert one more element here. So let us insert 90 now. Now we want to insert 90. This element we want to insert. Same process, check if the queue is full. Now you see, what is f? F is 2, and what is r? R is 1. Now I'll check by using the formula r plus 1 mod 5, is it equal to f? Is it equal to f? Now what is r? R is 1. 1 plus 1 mod 5, is it equal to f is 2, right? 1 plus 1 is 2, mod 5, is it equal to 2? 2 mod 5, that means when I divide 2 by 5, remainder is 2. 2 is equal to 2, right? So that means the queue is full. That means if I go to next location for insertion purpose, the next location is already occupied by an element, that's why f is there. So this is the queue full condition, and we have encountered this condition for inserting 90. So for 90, we'll say that the queue is full, there is an overflow, right? So this is how we'll perform these operations on circular queue. Now again, the point to note is circular queue is exactly similar to linear queue, only the difference is this movement to front and rear, right? This formula, right? R equal to r plus 1 mod 5 and f equal to f plus 1 mod 5. So these formulae are deciding whether the queue is linear or circular, right? Okay, so I hope you understood, you will enjoy this video. So in the next video, we'll see the implementation of these operations. We'll write the code, C code, to implement these operations on circular queue. So see you there. Thank you.